one solution for all the countries. However, we are already solutions available with our product for IMO 3 regulation, which will meet the IMO 3 regulation, which has got most stringent CO2 requirement. So our products are available. And we are also investing on very new technologies. It could be biofuel, hydrogen fuel, and other dual fuel solutions. The continuous R&D is in progress. However, it's not clear for us yet that which is the best solution for the whole world. So it's a continuous progress is happening, and very soon we will be coming out with the technology which can be adopted in many countries, and including India. So we are going into the collaboration and cooperation with many technological companies. Being transformation is more important for us for the futuristic. So we are also working into parallel hybrid and electromobility technologies. So we are cooperating with many technological companies. We all know that our engine manufacturers, colleagues also here, it's going to be collaboration in future. It's nothing like one company can do anything. So it's a collaboration and cooperation is going to be the future. I'm sure for the shipping companies in India also will have a similar approach towards the green technology. So on the technology, we should be ready, like the engine companies are always driven by the Paris Agreement. We are very much in alignment with the global requirement. However, there is a little bit of need to focus on some of the purchasing policy as well. My colleague Kulkarni has already touched this point. It's a high time to focus on the fuel efficiency, carbon reduction, and particularly the total cost of ownership. So these are the things which will drive towards achieving our objective. I'm sure many companies are already looking at. It's not only the purchasing price, it's also need to look at how we can contribute to this environment with a lower carbon footprint. It's all our responsibility. So there will be various options from the technology companies to maintain the existing products and also for the futuristic. We will be very happy to support from the technological solutions to precisely come back with how to align with Make in India. Volvo Group has already opened an engine manufacturing plant in Pithampur in cooperation with the Eicher Group. So this is a very good example that how Volvo Group is looking at a new technology and development to contribute particularly in India. This is an example that we are very happy that India has made as a platform to produce engines for the global. That is a big change. The whole world is looking at India. This is a great opportunity for us, and we are certainly feel that we are early birds to produce engines in India. So it's more important to look at to the objective of achieving the carbon footprint. Regulations are very important to be enforced. There are several areas which should come under regulations in India. Of course, there will be a cost applicable to this. This is how we should work as a cooperation with the various stakeholders. Of course, we will continue to go ahead with the technology available for the future and also to the current scenario. Thank you very much.
Yeah, thank you. Thank you, Gopalakrishna, for that insight. Yeah. So now I'll turn to my next panelist, Commander Prem Varadarajan, from Cummins, and so he's leading the marine engine applications there. I believe you have recently carried out a global international survey on future fuel candidates, Cummins. So from your survey outcome, and what can you tell us as an engine builder's perspective, and also what the trends you see globally, and how we can adopt that in an Indian scenario, particularly on coastal shipping. Yeah. Over to you, Prem.
Thanks, Chairman, sir, for having me on this panel. Industry leaders, delegates, and my co-panelists. So like Mr. Senthil Kumar put it, I think the coastal ships, tugs, passenger vessels, short-run passenger vessels are going to be the focus for the coastal one. And in that, we are somewhere looking at 800 kilowatt and less in propulsion power and 500 electrical kilowatt in diesel generator applications is what I would think. And as Cummins, we are poised here just right to be there. So Cummins has a history of leading through technology transitions. And today we are on the cusp of a big technology transition. And we are going to work with our customers in this decarbonization journey. So what I want to just put out briefly on the screen here is two important things that recently happened in adjacent segments to marine. Marine always has a, the automotive sector is first to adopt somehow, and then it percolates to marine. So a few days back, you would have seen Tata Motors and Cummins signed a MOU for Tata Motors to have all sorts of alternate fuel technologies for their automotive applications. This includes hydrogen-powered internal combustion engines, fuel cells, and battery electrics. So this was something significant as a mega trend that we see. So Cummins is betting big on hydrogen fuel cells. We are also betting big on battery electrics. So we see some other fuels as transition, but when we eventually get there, it would be battery electrics and hydrogen fuel cells. And to answer the question, these technologies would come to India. I think this slides answer the question. The first hydrogen fuel cell that Cummins makes would be made available to India, to Tata Motors, who's our partner here in our automotives. So I felt these are very significant mega trends that I need to put out at the beginning. So there are 4 keys to adoption that I would like to also point out. The technology readiness, where I think our co-panelists put it very effectively, including the last speaker, Mr. Gopalakrishna. I think that there is something that is attached to all these things. So it comes with a certain effort, time, and cost. So technology-wise, we engine makers would see to that we are ready in due course of time. The regulations would have to support us, the safety to produce this energy solutions. Infrastructure-wise, the government need to support us in making those fuels alternatives to be available. And there is a total cost of ownership that the customer has to be ready to pay for, right? So Cummins will continue to work with all these stakeholders in the field of energy sources. So low carbon fuels, green hydrogen economy, decarbonization grid, all that has been talked about. In terms of power solutions, Cummins would come out with advanced diesels, the existing diesels with very low sulfur fuels and further reduction of emissions. We would also look at gas engines, which are already there in any case, mainly for this sub 800 kilowatt power for coastal and passenger ferry. This would be very suitable. And moving a little ahead would be the battery hybrid electric, and the fuel cell electric. Now to talk about how the market is perceiving all this, we did a short survey, and I must thank our co-panelist here from MAN as well. So MAN has, the next slide I think. So these are drawn from a few studies that MAN did, and a couple of slides after that you would see of Cummins. So what we see here is, in the short term and the medium term scenario, liquefied natural gas, synthetic natural gas, or the e-gas, biogas are taking the lead, closely followed by MGO, ultra-low SFO, and very low SFO that we also have now. So this is in the short term and the medium term. Also, future fuels are on the rise that you can see, ammonia and hydrogen. I want you to look at that top slide first, the top square first. You will see that ammonia, hydrogen, methanol, and the biofuels are also coming close second. So this is the short-term and medium-term scenario. In the long-term scenario, the bottom one, please see that the 4-stroke and 2-stroke are behaving a little differently. The 4-stroke side, a different focus can be found with hydrogen taking a clear lead, which is what I said as Cummins. All our engines are 4-stroke engines. The coastal part of what is required is also around these engines, be it a diesel generator or a propulsion engine. And this is where we are also taking the direction there. On the 2-stroke side, yes, they're all going to be long-distance ones, so it would be a liquid-based fuel, be it a methanol or a ammonia, as the other speakers spoke about. So what factors are relevant? I don't want to get too technical here, but yes, just to give you a nugget of information, you'd see that the volume of fuel that we need to store, when you compare it with diesel, battery takes 10 times more space, right? Hydrogen takes 5 times more space. So these are things the ship owners and shipbuilders are going to think through when they put the space claim for all these kind of fuel storage. Similarly, on the weight side, the gravimetric side, battery is going to weigh 90 times more for an equivalent power output as the diesel was doing today, right? Ammonia is a factor of 2. So as on date, we don't have a fuel which is as efficient, as energy dense as diesel. So this is a transition, this is a journey that all of us will have to walk through. And this is what, it is a but obvious, stating the obvious that we are moving in that direction. So lastly, on a type of few conclusions that we thought we would put out from the survey. Yes. So conclusion is, yes, it depends. So like I said, for a low distance, limited power, the coastal kind of applications, hydrogen as a fuel, it could be internal combustion hydrogen, hydrogen ice as we call it, or hydrogen fuel cells. Again, for a low distance, limited power, it could be a battery electric. So the first 2 bullets are what we are really looking at for coastal applications. The third bullet is a long distance high power, where ocean going vessels are going to look at fuel kind of liquid kind of fuels. That's where the methanols and other gases do come in. If there are limitations on the tailpipe emissions, the taxes, as we call it, the emission regulations, then physical hydrogen carriers like ammonia, those kind of things would come in. And last bullet that we see there is, the well to shaft emissions. Right from the time you bore and take out the fossil fuel and you applicate it, there is regulations all along. Similarly, whatever alternate fuel we are talking about also will have limitations and taxes to be paid right from the time you harness it and applicate it. So when you look at that kind of a thing, then I think the methanol, FAME, hydro-treated vegetable oils, the biodiesels, the Fisher Tropsch ones, those do well. These are our broad findings that I would like to summarize. Thanks.
Yeah. Thank you, Commander Prem, for that insight. It's interesting to see that the future fuel, future alternate technology going to depend on the vessel type and also the operational profile. Very nice outcome from the survey. So my next panelist is Kiran Dakle from KPIT. May I turn to Kiran? KPIT has extensive experience in fuel cell transportations. India's first indigenously built hydrogen fuel bus. They are the technology partner, and recently we found an announcement last week that Cochin Shipyard is going to build the first hydrogen-fueled catamaran ferry. I think KPIT is again the technology partner. So I would request Kiran to give an insight on fuel cell application in maritime, particularly on Indian context, and as well as whether the fuel cell components, whether it is the fuel cell itself and or the BOPs, whether this can be manufactured here in India, and also if you can touch upon the skill set requirements as well. Over to you, Kiran.
Thank you, Chairman. Thanks, INMARCO, for giving this opportunity to be present here for this fantastic panel discussion. KPIT basically is a software company. We are well known in the automotive sector. So if you look at any overseas vehicle, you will find KPIT's software running inside that vehicle. In 2010, KPIT ventured and started a technology solution group, wherein this group worked towards, making the transportation greener, smarter, and sustainable. So, having said that, KPIT started, its journey on this path in 2010. We developed first hybrid electric vehicle powertrain for car and bus application. Then eventually we went ahead and we have electric vehicle powertrain also under our belt. And with our, electric powertrain, VCV, Volvo Eicher, they have, commercially launched their first bus where, KPIT's powertraining is running. Then from last 6 to 7 years, we are working on the fuel cell. So when I say fuel cell, you must be knowing fuel cell, there are many things, fuel cell stack, its module, then entire BOP system, then compressed hydrogen storage system. So if you look at that, KPIT is, developing the indigenous hydrogen fuel cell stack. And we have a fuel cell stack ready with us. We have tested our technology first on the sedan-like car. Then we tested our technology on a bus as well. And now, we are fortunate that, CSL has given given an opportunity to develop the India's first fuel cell catamaran vessel. So this vessel is a 24-meter, 100 passenger carrying vessel, wherein we'll have around 60 kilowatt fuel cell system. So when I say fuel cell system, then KPIT's indigenously developed fuel cell stack is there. Then the entire forward powertrain. So forward powertrain means there is a motor controller, then vessel control unit, and the BMS. These all components are designed and developed by KPIT. Only BOP we are sourcing from outside. When I say sourcing, that means we have as per the application we have jot down the requirement, and according to the requirement we have selected the component and we are integrating the entire system at our end. So that's our capability which we have built in last